Welcome to Math Physics Engage. In this video, we will be looking into real-world application of the rectangular coordinate system and graph. So before we start, I will greatly appreciate if you subscribe to my channel to watch similar content. So let's get started. Now here we are given a problem about renting a truck. And to rent a truck, we have a $75 fee that is being charged per day, irrespective of how many miles we drive. So I have a fixed cost of $75. In addition to that, we have a 20-cent fee for every mile we travel. Now, what they are asking us is to write a linear equation that would express the total cost per day. So we need to figure out what is the total cost of renting the truck per day. Now, using x to represent the number of miles we travel. So they are telling us represent the y with the cost and x to the miles, and graph this function and find the total cost for one day if we travel 70 miles. Now, once we have read that and highlight the key terms given to us, let's write them down. So we have the total cost, that is y, and this total cost consists of two costs. One is I have a fixed cost irrespective of the miles I travel, that is charged per day. So I have $75 per day. And in addition to that, we have a cost of 20 cents per mile. And that represents our total cost. Now, the problem states that use x to represent the miles and to solve for one day. So we can modify and plug in those values here. It will become y is equals to 75 times 1 plus 0.2 times x. Okay, now I have this expression here. Next, let me rearrange that so it looks familiar to some of the concepts we have already covered in our algebra class. So this equation of y is equals to 0.2x plus 75. Now, if you look at this expression, it looks quite similar to our point slope relation to represent a linear line. So I have y is equals to mx plus b. This is the equation of line having the slope and intercept. So by comparing these two equations, I can say that my slope is equals to 0.2. That is our rise over run, and 0.2 I can write as 1 over 5. That will be equals to 0.2, and the intercept is equals to 75. Now, once we have this information, let's go ahead and start plotting this thing. So here on my graph, on the horizontals, I will take the miles as my x-axis. So x is the mile, and on the vertical I have y, that is the cost. Since they are starting here, so this is my origin or reference point. So let me plug in some numbers: 10, 20, 30, 40, 50, 60, 70, 80, all the way to 90. Similarly, on my y, that is representing the cost, I have 10, $20, 30, 40, 50, 60, 70, 80 and 90. Now to start with, first of all, we have to plug in the value of intercept here. So the intercept value that we are given is 75. Let's identify that. So I have 75 as my initial fixed cost per day. So if I have the value of x equals to 0, the y will be equals to 75. That is what's happening here at the origin. My value of x, if I do the x, it's equals to 0, and the starting point for the cost is 75. Next, I have to identify the points on the graph using my slope. So here you can see I am given rise over run, that is 1 over 5. In other words, I am moving 5 blocks horizontally and moving 1 block vertically. So I'm just rising 1 blocks and running 5 blocks. So let's see, we can identify some of these points here. So 1, 2, 3, 4, 5, and 1 up. Same way, 1, 2, 3, 4, 5, and 1 up. 1, 2, 3, 4, 5, and 1 up. Okay, so here you can see I have identified 3 points using my rise over run. Now let's connect these to form our line. Okay, so this is our line that we have, and we have plotted this function. Now, once we have done that, the final thing they are asking us is to figure out the total cost if we travel 70 miles. Now, there are two ways of doing that. One is I just directly go to the graph. On my horizontal, I have 50 here, this is 60, and this is the 70 mile. So moving vertically up wherever this is intersecting my graph, I take that point and move horizontally and count what value we have here. This will give us our uh, the value of total cost. Now here you can see I have 80 here, 85, and if we have drawn the line using the scale, we will get exactly the same value. Right now I'm saying it is around 88, and if I was straight enough, 88 or 89, somewhere around that point we have this thing. We can also verify that by plugging it in our equation shown here. So let's do that and verify what number we are getting. So y is equals to zero point 0.2, x is the number of miles, that is 70 here, plus 75. If you solve this thing, it will become 14 plus 75, that is equals to 89. So we were pretty close. If you have used the scales, the rulers, it will be exactly at 89. So that's how we utilize the linear functions and rectangular coordinate systems and graph to solve some of the real world examples. I hope you like the video.